So here is for chapter 1, or chapter 0, sorry. This just gets into who should use Rust, why should we use it, where is Rust's niche. So starting out here, it's good for teams of developers. It gets into all of the downfalls of low-level code. So lots of bugs that aren't caught very easily, or you have to have some deeper knowledge, are caught by Rust itself. The compiler helps you out quite a bit in catching those bugs. So an example of how Rust handles something better as opposed to JavaScript. If you have an array that's 3 elements long and you index element 999, it'll give you undefined. But instead, if you do that in Rust, it will panic. It'll crash the program. And there are better ways to iterate to avoid indexing as well, but that's just one of the many examples. Instead of giving you some undefined behavior, it will completely stop or force you to handle it. Some other things it gets into is the ecosystem itself. So for JavaScript, once again, if you want to work with a team of developers, you're going to have to set up some defaults for your linter, your formatter. You're going to have to decide all of that. All of your defaults for JavaScript, personally, I need a lot of things for TypeScript to get it to work, like testing, setting up TypeScript itself with various things. Some libraries don't support it that well either. So all of that is handled just by running cargo new. You'll have a formatter with sensible defaults. The linter works very well. It'll teach you how to code better Rust. It's pretty opinionated, which I enjoy. Beyond that, it mentions students. So, like mentioned above, it's good for anyone who isn't familiar with those lower level concepts, because it'll guide you away from doing things, certain mistakes that just aren't caught. So, and then companies, I think that's equivalent to teams of developers, or at least similar, but they mentioned some good things in here. It can be done, lots of things can be done with it, not just lower level things like a CLI app. You can build DevOps tooling embedded. You can build parts of like Firefox web browser are built with it. You can build your own UIs. Lots of things can be done. Some, open source too. Yeah, one of the big draws for Rust here, it's mentioning how it's very stable and fast. So bringing up JavaScript again, it will crash or it'll error if you do something, or it won't check those errors during compile time. It'll check them during runtime. So if you've ever seen, and other times it'll do like behavior you didn't expect to happen. So if you've ever seen object on a web page, if that were Rust, it wouldn't let you do that, but you can definitely stringify an object and just leave it there. So instead, you can be much more certain that your code will run well once you write it. And it's also pretty fast. It's around as fast as C++, I believe. Yep, they mentioned things like zero cost abstractions right here. So things like iterators, bring up JavaScript again. If you try to use methods like map and reduce, if you run multiple maps and then a filter, it creates a brand new array for each of those. But for Rust, the compiler will optimize out those things. You don't have to worry about them hurting performance. They work just as fast as a regular for loop. Beyond the added benefit of not being able to accidentally go out of bounds. Yep, and then it goes into here. So who is it for? If you know a programming language and you're interested in Rust, it's perfect. And then just in general mentions that we should read it from front to back. So perfect here. We're going to read it front to back. We might spend some more time on specific pieces depending on how long they are. Like for the next chapter, I'm planning on just doing this whole thing because ultimately it's just installing and doing hello world, running some different commands. Yep. And then this whole thing just goes into here's everything we'll be learning. And ultimately it ends up with a multi-threaded web server. I think that's pretty good summary here. Any general questions? Anyone had any comments, concerns, questions on this chapter?
I'm sure we'll get into it eventually, but it might be worth mentioning some of the benefits that you have in Rust just because it's a compiled language as opposed to something like JavaScript for any of the folks who haven't used something like C or another compiled language before. Because there are things like on top of that, like that Rust does in particular, but like you were mentioning C and C++. And that's, I don't know, just thought it might be worth mentioning.
Sure. Feel free to mention some if you have any. I was planning on leaving it for some of the later chapters where they go pretty in-depth.
Oh, did they actually cover some of that?
They cover some parts of like here, like we have benefits here that helps us not make some of those lower level mistakes, like indexing out of bounds, which is what I mentioned a lot. But there's some other things that you can run into with garbage collection or memory management that Rust helps you out with. But yeah, we get into it sometime later. I didn't want to get too in depth to start.
No, that's fair.
But yeah, compiled language. So JavaScript is just in time compiled. So code in the hot path will get more optimized than certain other pieces of code. Certain pieces of code get compiled or changed differently than others. But for Rust, the compiler will compile everything beforehand, so you don't need to worry about doing that on the fly. You are forced to give it a lot of information so it can do a lot more. So for example, you have to tell it what every type of everything that goes into a function is if it can't guess what that is. So it chose the trade-off of instead of inferring what a type is, you have to tell it explicitly. So that allows for much better error messages as well. And just in general, if it knows what type something is, it can optimize it much better. JavaScript gives you the option of doing lots of things that aren't optimal for the underlying implementation of the engine, but you can't really do that in Rust. It does the opposite. But not to discount the JavaScript just-in-time compiler, it's super good. Did anything else that you wanted to mention on that? Did I cover everything?
No, I just wanted to bring it up.
Okay.
Because I haven't done a lot of like C programming or C++ or anything either, but
I personally have not either.
Yeah, I don't know where like more of the optimizations come in Rust, like for that, like for actual like CPU optimizations for like all their weird like typing systems and everything that's in Rust that isn't in like a simple language like C. I don't know how all that comes into play, so So you were thinking of doing one chapter a week? Was that sort of the plan, or maybe like 2 weeks if it's a big chapter?
Yeah, something like that. Depends on what it is. Like, definitely first chapter is like a week, second one as well. But going into later chapters, they're quite bit more complicated, like concurrency. So we'll in testing, we'll take some more time on potentially.
Ooh, smart pointers. Yeah, those later chapters should be fun.
Yeah, gone through quite a bit of the Rust book, but we'll see once we get into those later chapters. From what I'm seeing, I don't think it does anything specific over C++ for compiler optimization specifically.
Right, yeah. I remember, I haven't looked into it, but supposedly, like a lot of the features in C++ are covered, I guess, by Rust's like either comparable features or something that includes it, stuff like the smart pointers and whatever other stuff. I haven't looked at a chart for like performance comparisons in a while. Is Rust still pretty much just like neck and neck with C++? Because I thought it was a little bit slower.
Wow, it's compared to C++ here. Yeah, if anybody has a good chart, feel free to send it over. I'm not too sure. Let's look at this one. As always, benchmarks are benchmarks. I think more than anything, looking at these charts really shows me. So we have Rust, Go, Java, and Python here, and then Rust is very flat, whereas things like Go, the latency is going up and down over and over, and then Java, here's a big spike, and then more
That's
and more.
to initialize the JVM, I guess.
Yeah.
But what are those colors? I don't understand. What is P50, P90?
They're
P99?
the percentages,
Like if you
percentiles
scroll
of latency.
down-
So this is response time, I believe. Let's see.
Eric.
There's response per second. Okay, these are responses per second. So here is the 99%. Oh yeah, it seems noisy. They saw the same thing. And then the cold start spike. So
What does it say in the chart? Does it give any more details? Down below.
here it says, I mean, the orange here is P50. This is
No, I mean, like in
P90.
the table.
Oh, the table.
Sorry. Okay, it's just
Yeah, it mentions here it's
So
percentiles.
it says overhead in microseconds. Is what it says.
Oh, these are microseconds. Oh wait, where?
It's the caption on the table. This is overhead.
Where does that say that? Am I missing it?
Right under the table. It's in
Oh, overhead in
little-
microseconds. Okay, yeah, cool.
So it says so those are all libraries doing like just TCP traffic or something, because it's HTTP tunnel, TCP proxy, Netcrusher. I assume those are comparable, I guess. I was just wondering like what they were actually doing the performance tests on, because you said latency, but I didn't see that anywhere.
Yeah,
like, what
so
they were referring
TCP
to.
proxies
Oh,
for so here's C, C++, Rust. But
so
comparing
it's network
to
IO stuff in general, because is it just TCP? Could you link that article?
yeah, for sure.
Thank you.
Yeah, I've seen P99s or like P90s, so as percentiles for latency, but feel free to correct me, anyone, if I am misinterpreting that.
P90 latency.
P99 latency is the 99th latency percentile, so 99% of requests are faster than the given latency number. So overall, like this blue here is a P99, so 99% requests are faster than this number.
Okay.
And
so,
like
yeah.
these are the most changing ones because of that. So with Rust, it's a whole lot more consistent.
What is the
but
board?
with-
It just says rate.
Yeah, so you really kind of want to ignore the orange here for a second, because the orange is good. The orange in the graph is good. That's the amount of requests per second these languages can handle. And you can see Go and Rust can get up to 25,000 requests per second here. The blue, yellow, and green is what you want to focus on. So you can see like Rust, like it's lower, I guess, what is that, latency overhead? Those are the three, yeah. Lower latency overhead in those. So you can see Rust is very, very linear there. Go is very performant with Rust in the P50 and P90s. But when you go to the P99, Go starts to become more latent than Rust, as indicated by that blue graph. And you got to remember, Go is a garbage collected programming language. So this graph actually makes sense, right? It grows up to the right, Garbage collection happens, drops back down, grows up, and then so like this makes sense. Java is like, what the hell is that blue spike?
Well,
there?
that's
Like, that's probably
initializing the JVM or something.
That's
like
probably
it
the
has
JVM.
to-
Exactly.
Yeah.
That's probably the JVM booting up. And then Python's like, I can't even handle 10,000 requests per second without latency. You can see the blue bar is higher than the orange bar, which kind of sucks. Like it has a shit ton of latency compared.
Okay, so what is the rate? So that's just like the baseline number of requests that you're sending, or something like what?
Yeah, it looks like they're hitting requests per second. Like they're scaling up requests per second, and I guess they start at 2,000 requests per second, and then they bump it up every 5 minutes by 1,000 requests per second or something like that. Or
this
sorry,
graph is so confusing. They have two different lines on here. Yeah.
Oh.
Yeah, the right axis is the request per second. The left axis is the microseconds or something, whatever it is.
What? How?
I think that's what that is for this graph.
They have to define it. Where is it? So
Yeah, let's see if we can find a different article. I saw something good.
well, they didn't even compare C++. I don't even care about this.
I think they did. It's
They
up
did
here.
at the first.
Oh, is it the first one? Okay, I was.
Yeah, here. C,
the second,
C++,
it's like it's just
and Rust.
Rust, Golang, Python.
Yeah, they
Java,
went
who
for
cares? I wanna know
memory safe
C++.
languages versus this. So here's network I/O, and this graph is a whole lot shorter.
Yeah.
Okay, so orange is the rate on the right, and this is on the left is the microsecond. So I don't know which. Oh, this is what is this though?
HA proxy is a like a layer 4, layer 7 load balancer application.
I see. So it's wait, is it the number of requests per second, and then the left is the number of microseconds per request?
That's what I'm still trying to figure out. The left hand.
I'm looking
it's
at
right
it and
here.
I feel like the math doesn't work out.
Yeah,
Is
in
the left is
microseconds for what
microseconds
though?
for the P50, P90, P99.
But
It has to be-
microsecond?
latency.
Yeah.
If it's online with the number of requests like total that you sent, like or per second, if that's what the right column is, then it has to be like the inverse. It has to be.
Well, yeah, the right is definitely the request per second, and that's only the right hand side is just for the orange part of the graph.
I love how I ignored all of this important information here that would have answered our questions. We just skipped to the graph.
Yep. I'm just trying to figure out like if the left hand thing it's microseconds, but of what? Of additional latency, of time to service a request? That I don't understand.
I didn't understand this piece, but yeah, this is baseline C, C++, and Rust. They used perf gauge. I don't think that's helpful.
Yeah, that's weird. It looks like it almost matches up. So weird. 30K. 1, 2, 3. And this one.
It's measurement or latency measurement resolution. Oh wait, that doesn't tell me anything. That's just like the unit we're using, right? The measurement resolution.
I don't know what that means. Latency measurement resolution. Bizarre.
You should click the other graphs that they gave for like CPU and memory usage.
Where are they? Did I miss them?
He linked to it. I don't know.
Oh, here they
very
are.
interesting. Very interesting graphs here.
How am I supposed to know what any of these are every time? Okay, it's right here.
Yeah, I guess that's the same thing, like the 4 different languages.
How am I supposed to know which languages? It says C, C++, and Rust, but which one?
I think
There
it's
it is.
baseline C, or sorry, baseline HA proxy, C++, and Rust in that order.
And what does baseline mean here?
Good question. I don't know what this author means when they say baseline.
Maybe that's assuming like literally no latency.
Okay, I think. Did anyone else have anything else they wanted to talk about before we just sit here and look for benchmarks?
Has anyone not used the compiled language before? Like, has anyone not like ran a compiler before they can run their software? Starting to understand the Rust versus Go Twitter countries. Yeah, Go is in the conversation, but it's just different, right? It's targeting a different audience. Rust and C++ are definitely the ones that are like Rust is definitely taking aim at C++. And Go is just sitting there like, yeah, I can do some of what you do, but I have this whole other market that I'm looking at, so y'all can have the systems level market. I got to show you all the Gophers I have behind me. I have like 3. Sorry, 4. I have no Ferris crabs though, so I gotta
Ooh,
get one of those.
Really thinking of getting one?
Get crap.
Me too. Oh, I like this white paper, Remy. Honestly, if you're using any of these languages, Go, C++, Rust, like you probably don't have to worry about performance for quite a long time. Especially if you're coming from something like JavaScript or like a Python or something. You're going to see fantastic performance. It's only these performance measurements only really matter when you're writing like super low level software that has to be super performant and not waste any sort of CPU cycles. Like embedded systems or like the kernel, right? Like then we can split hairs over performance. But
I mean, there's
if you're coming from the
people
web,
running Rust on
yeah.
embedded systems yet?
Yeah, Oxide's a whole company doing that.
Holy
Yeah.
shit.
I interviewed for a
Yeah.
company that did IoT for Rust.
Yeah, Rust is huge in that.
That's cool.
Primarily because like its memory safety guarantees and its lack of garbage collector. Right? Like
Okay,
yeah.
you said Oxide, and the first thing that comes up when I Google Oxide Rust is the modding framework Oxide for the game Rust.
Yeah. Search Oxide computer.
Yeah, that's the next
Yeah.
search result.
Yeah, they're pretty much everything they do is Rust. But they made that choice, right? Because they wanted those guarantees. But yeah, my question was like, so I know a lot of people are here are used to like running like programs, like you write a file and then you just node run, or node index.js or whatever. Like, it's different in this world with compiled languages. You have to actually compile your code first before you can execute it. Whereas in JavaScript, it kind of gets compiled on the fly, depending on what your runtime is. So that's going to be probably one of the weirdest differences at first. And in Rust, the compile times are slightly slower than some of the other compiled languages out there. Go has really fast compile times, or Rust is kind of in the middle. Not super fast, not super slow.
Yeah, it trades off the memory safety and all those checks for the speed, or for speed. I think JavaScript could probably relate, or JavaScript users could relate, because building your code, running your code, you have to minify, run all kinds of stuff for typical applications to build them. Like if you're building a React app, you gotta build the production version. You're not just gonna run whatever you have.
Yeah. Exactly.
Babel, all that kind of stuff.
Good old Babel.
But yeah, I agree with all of that stuff. If I look up how to make Rust server, I'm not going to get Rust programming language, how to make a server. I'm going to get how to make a server in the Rust game.
Well, honestly, Rust and Go are very poorly named languages. Like, Go is horrible. Try to look for anything about Go, and it's miserable to search that up.
I mean,
like, Go returns. Okay, what does that mean? Go where to return what?
I mean, C wouldn't be a great name either, except that it was like the first one. So
that's true. Yeah, I usually put Golang if I'm not getting good results.
You'd put like Rustlang. Does that work?
I do that sometimes too.
I type like coding or programming.
Yeah. See, if you type Rustlang, the first thing that comes back is the docs, which is good, I guess, but not always.
I mean, the docs are amazing, so I'm not mad.
I mean, yeah, it's a good place to start.
Yeah.
Okay, we're nearing the end of the hour. Did anybody have any final thoughts before we get into what we're going to go for next week?
Go for, you say.
You're funny. You bastard. Okay, how dare you?
We'll see how we fare this week.
All right, I have to get the Gopher home.
Okay.
I hope that one worked. I think it worked.
Oh yeah, it worked.
Yeah, let's go.
My camera on.
Okay, so next week we'll be going over chapter 1, which is figuring out how to install it, which I have never had an issue with, but I've only installed it on Windows and Linux before. Well, I've installed it on Mac as well, but
I was about to ask, what else would you install it on? And then I remember.
I mean, yeah, there's Mac. I've installed it on Mac, but I have never, like, it wasn't a Mac machine. It was a Mac machine running on a VM, so I don't know if that counts, because it was very, like, containerized environment. But I don't think it should be difficult. Yeah, and then
yeah, honestly, like the Rust's like the whole tool chain that you can install with like Cargo is like the best I've ever used. I feel like with compared to like other tools, like if you're trying to set up an environment to like compile C code, or even like working with like C# or whatever, because you have to use like Visual Studio if you want to get anything done. Like with Rust, it's just cargo install, and then like everything just sort of works together. You'll never want to use JavaScript again. Yeah. Yeah, exactly. Yeah. It's all just sort of built in and easy to install. And I love that like the test like framework is built in as well.
Yeah. I think that's a huge one.
Yeah.
Like, I don't know, JavaScript is one of those languages where it was designed in 10 days and it was designed for a purpose. And so no thought was given into any of its tool chain. Rightfully so, right? Like wasn't built as like that. It wasn't built like that. But Rust, Go, they're really, really good with their tool chains. Go has a fantastic tool chain. Rust has a fantastic tool chain. And I think that's one of the reasons why you're seeing it win out so well against like C and C++, because the tool chains in those languages aren't that great. They are now.
I mean,
like,
they're
not, they are now because so many people use them, but it's not like a first class tool chain.
Right. It wasn't designed with those in mind. So they're still sort of tacked on.
Yeah, first class is
programs that you
huge.
have to configure.
Yeah, go to like any big JavaScript project. Like go to their GitHub repo or something. I'm hearing myself, and it's great.
No, you're good, Eric.
I hear myself. I'm scared. But like, yeah, go to any big JavaScript project, and you'll see the 500 different files they have in the root. Package.json, prettier, ESConfig, freaking ESLint, whatever. Like, it's miserable. You spend more time making files than you do coding.
Oh yeah, looking through this chapter, a lot of the stuff we were talking about, like if you haven't used a compiled language, they make you do it the hard way here and figure out like how do you set up a project without cargo at first, and then you're compiling and running our separate steps. So we got everything in there. Should be pretty good intro. Yeah, for next time, I'm planning on going over this. So finish chapter 1, and then if they don't have all of the good extensions for your IDE, then I will make sure to mention those.
And then we'll make everyone install Vim.
Thank God. Neon, see, I knew I freaking kept you around. Thank God.
Yeah, that's part
Somebody
2.
here is learning in this Discord.
Section 1.5 or 1.4. I guess these already have 1 point.
Listen, all of you in here are going to get to the point where you're like, I hate VS Code, and you're going to find an editor, okay? One day, you'll get there.
I'll go over VS Code extensions if anybody wants to go over Vim. If you use Vim, though, you should be able to install that yourself. Figure it out.
Once you get to the point where you don't have to use your mouse for a lot of things, you're like, why didn't I do this 5 years ago?
It's so hard to go back.
Yeah, exactly.
I have actual difficulty like using an IDE or any other text editor that I can't use like Vim motions, and I'm just like, it's painful. It's painful to my fingers trying to type things.
I did an interview where they didn't have a Vim mode like editor, and I felt like I just learned programming for the first time. Like you're
just making typos all over the place, trying to like do like JKLs.
Slow. I felt so slow. Like, oh, can you do Hello World? Give me a second. I'm hurting right now.
Phrase. What is phrase?
I was in undergrad. Anything but
phrase.
Now you make me look it up.
I don't know. I've never used like a Mac as like my actual main machine for anything.
Editor. Phrase is a lightweight but powerful text editor for macOS. That sounds scary. Last update 13 years ago. It's 11 years ago.
That's about right. Yep. Thanks, Apple.
Any final thoughts before I end this off?
Use Vim.
Okay. Understandable.
Damn it. Oh man.